Okay, we have three more problems on the surface area of prisms and cylinders worksheet, just based on the difficulties I had with trying to get the picture and the work in the frame at the same time. I decided to just cut out the picture here for those three that we do. So we're going to do 1 and 8 on this video, and then we'll do 6 on the next video. So if I were to just sketch, this is a hexagonal prism. If I were to sketch what the net of this looks like, we'd have one hexagon. Hopefully yours looks better than mine. And off of each of the sides here, here is the cat making his presence. On each of the sides here, we're going to have a rectangle that comes out. And then off of one of them, we'll have another hexagon. I was just getting ready to make an octagon. That's not it. So it's going to look something like that is the net. All right, there are other configurations that you could do, but essentially that is the net. So when we go to find the surface area, we're going to have 2 hexagons that we need to find the area of, and then 6 rectangles. So the surface area of this is going to be 2 hexagons and 6 identical rectangles. Right. I'm going to suggest we do the rectangles first because they are way, way, way easier than the hexagons. So what you should see is that if this is one of our rectangles, that the base of it is 11 and the height of it is 4. We see that on the other side over here, right? So we're going to have, and I'm going to leave plenty of room here, we're going to have 6. Again, the formula for a rectangle is length times width, so we've got 6 times 4 times 11. This is a bear, so let's do that off to the side here. So first of all, we have to assume that we're talking about a regular hexagon. And if you remember from our packet that we did on interior and exterior angles and polygons, you remember that to be regular, all angles and all sides have to be the same, right? So if we don't know that, we cannot do this problem. They don't indicate that that's what it is, but we're just going to have to assume that that's what it is. Otherwise, we can't do it. So first of all, if you remember, the way we found the sum of all the interior angles was we just started at one vertex and then connected it to every non-adjacent vertex from there. Counted the number of triangles we got. So here's 1, 2, 3, 4. Each of those triangles is 180 degrees. And so then we found out that the measure of all the interior angles is 720. And then since this is regular, each of the 6 of them are equal measures. So we're going to do 6 into 720, which means each interior angle is 120 degrees. So let me draw another regular hexagon again, or the best I can. All right, so that means that each of these is 120. And each of these sides is the same. So what I'm going to do with this is the center of the hexagon, is I'm going to draw from each vertex there into the center like that. And what we find then is this 120 degree angle is split into a bunch of 60s. So 60, 60, 60, 60, 60, and so forth the whole way around. Each of these angles is 60 degrees. Now let's just look at one of those triangles. If this is 60 and this is 60, then this also must be 60, which makes this an equilateral triangle. And then let's look at it even more. If that's an equilateral triangle, and from this vertex up here, I drop a perp, then what I end up getting is a right angle with this being 60 and this being 30. And so this is a 30, 60, 90 triangle, which is nice because we know a lot about 30, 60, 90 triangles. So let's go back again to our picture, which says that this side right here, which is the side of the hexagon, is 11, which means if the whole thing is 11, then this is 5.5. Right, and this is opposite our 30, which means this is our x. That means this is our 2x, which makes this 11. And then that makes this 5.5 times the square root of 3. All right, x, 2x, x root 3. So why do I need to know that? Well, if I can find the area of this, then I can find the area of this. And if I can find the area of this, I can find the area of this because it's 6 times the size of that. If I can find the area of that, then I just go back to my original equation here and I double it and I get the area of 2 regular hexagons. So let's find the area of this. So area of a triangle is 1/2 base times height. Area is 1/2. Our base is 5.5. And our height is 5.5 root 3. Oops. And we're going to use the calculator to figure that out. So 0.5 times 5.5 times 5.5 times the square root of 3 gives me the area of this is 26 point. It's 197.197, but I'm going to go with 20. Right, so the area of just this triangle right here is 26.2, which means that the area of this would be twice that. Actually, before I round, let me just multiply this, the 26.197 times 2. That'll give us a little bit more of an accurate answer. That means that the area of this, which is twice the smaller one, is 52.39. I think that'll give us a little bit more accurate than if we had rounded it our first one. All right, so then that is 52.39, which means this is 6 times that. So the area of the entire thing here, I'll go with the 52.39 times 6. The area of this whole thing is 314.34. So I'm going to fill that in up here. I need 2 times the area of the hexagon, which is 314.34. Okay, now we can do this. So we just plug things into our calculator. 2 times 314.34 is 628.68 plus 6 times 4 is 24. 24 times 11 is 264. So then we're going to add 264. And we get 892.68. Right, I got something slightly different than that on my answer key. My guess is it's because I started rounding here instead of waiting until a little bit further on in the process. But I feel like that is good enough right there. And our units were millimeters, so this is millimeters squared. Right, let me just recap that for you again. We drew the net. We realized we needed to find the area of 2 hexagons and 6 identical rectangles in order to figure out what the surface area was. We looked at the regular hexagon that made up the 2 bases, and we figured out the sum of the interior angles was 720, so each individual one was 120. We split that up into 6 identical triangles, which happened to be equilateral, and they were all 60, 60, 60. We split each of those in half and found that they were 30, 60, 90 triangles, and this side opposite the 30 was 5.5. We could figure out easily the other 2 sides, knowing our special right triangles, and then we used that information to find the area of this small triangle. We doubled it to get one triangle, one equilateral triangle. We multiplied that by 6 to get the area of the hexagon, and then we put that in this formula right here. All right. Again, if you started rounding after I did, you would have gotten 892.73 millimeters squared. If you just kept using the answer that you got for this without rounding it, and then doubling it, and then multiplying it by 6, and then doubling it again and putting it in there, it would have given you something a little bit different. Okay, next one I'm going to do is problem number 8, because I feel like this one's going to take a little bit less time than problem number 5 will. Yeah, problem 6. Actually, I think we're out of time, so I'll do 3 separate videos. So next one we'll do is number 8.